This lesson is very much about putting together what we've learned so far. So if we think back over the course, we started on lesson 1 with plotting different actions on the pitch. Then we got to lesson 2, which was our first model of value, which was the expected goals model. Then in lesson 3, we started to think about scouting, but importantly, in lesson 4, we looked at the expected threat model. We looked at both position-based and action-based expected threat. And that gave us a much more comprehensive model of value than the expected goals model did. And that's about as far as we got with event data. We paused a little bit in lesson 5 to look at randomness. And then in the last lesson, in lesson 6, we started to look at control of space. Using tracking data, how could we measure how different players controlled space while they were playing? And what we're going to do in this lesson, as I said, we're going to put things together. We're going to take the expected threat idea from lesson 4 and combine it with what we learned about pitch control and pass probability in the last lesson in order to give us now a complete picture. I mean, it's not going to be a complete model forever of football, but it's going to give us a very powerful tool in order to evaluate actions which include the spatial dimension, how the players are moving and so on. So just to recap over our overall approach, I've emphasized quite a lot. When we looked at lesson 3, I said it was very important when scouting to look at the context of the player. We needed to think about the actions that the player was doing and so on. And so this was, what is the player or the team trying to achieve? Then when we moved on to lesson 4, I said, well, we've got to be able to assess the value. And that's what expected threat was all about. And expected goals is also a value model. I also mentioned normalization. Normalization is thinking about, well, relative to who? If we're evaluating a defender, maybe if it's a left back, we want to evaluate them relative to all the other left backs and the right backs. We also came into the idea of adjusting for possession. If you're a defender, you need to adjust for the fact that the other team might have the ball when you're measuring these things. So normalization is all about adjustment. So we've got value, lesson 4, expected threat. Context, lesson 3, trying to think about what a player is trying to achieve, and normalization, which is also lesson 3, relative to what. And in the last lesson, and that's what's so nice now, is we're combining now in space. By looking at the space and the movement of the players, we can also think about how a run adds value, how synchronized pressing of different players add value, and that needs to be combined with the 3 other things we've got. So last lesson we looked at space. Let's combine it with everything that we've learned so far. If you look in the football literature about combining value with space, it can seem a little bit complicated. Like I mentioned with expected threat, there's lots of names for this type of approach. One that comes up most is expected possession value. But I like to think about it, and this is the key idea I want to get across here. I like to think about it in terms of the following. It's pitch control times expected threat that we're interested in. Really, we're going to do a point-by-point multiplication of where we control the pitch with how much threat is produced on the pitch. And that's one of the simplest and most straightforward ways of combining space with value. Okay, this sounds a little bit abstract, so I'm going to make it very concrete, but I want to just to think and keep that in your head, the idea that we're going to multiply pitch control by expected threat to get the value. Okay, so, and here are our two situations. So this is a particular situation. This is taken from data that we used in Hammarby. We're attacking up here, and we have the ball at this particular point. This is taken from a pass probability model, right? So the green team, which are Hammarby, have the ball, and this are the possible places that they can pass to. Here, there's a pass which 22 will get. Here, there's a pass that number 40 will get if the player is the right way round. And here is passes that maybe number 20 will get. It's a 50-50 ball. So this gives us our pitch control or our pass probability model. And that's what we did in the last lesson. And then over here, we have the expected threat, or in fact, this is the expected threat. It could also be an expected goals model, but it's the expected threat model. A pass very close to goal, of course, is much more dangerous than here. Now, of course, it's one thing, and this is an obvious criticism of the expected threat model. It's kind of obvious, right, that you should pass as close as possible to the goal. But this model says, well, of course, that's not possible. So passing here, well, the goalkeeper will get it, okay? So here tells you the value of making the pass, and if you could make that pass, you should. But here tells you, well, you can't actually make that pass because the goalkeeper will get it. And the same here, you can't make a pass here. Here it says that you have a particular value, but you look up here and you can't make that pass. And so what I mean by multiplying these two things together is literally this. We take the points here and we multiply them by the points here. This is actually a matrix of values between 0 and 1. 0 is that you'll never make the pass. 1 is that you'll always make the pass. And here is also a matrix of values between 0 and 1. 0 is that you won't score a goal out here, or there's a low probability of scoring a goal. And 1, well, 0 is no probability of scoring a goal, but here is a low probability of scoring a goal. And 1 is a pass where you'll always score a goal. So to illustrate this, I'm going to take another example. This is, I've got a video here. We looked at this in the previous text, and I said we could actually look to see where a good pass could be, where was a possible pass to be made. And we have Kjartansson running there on the right, really wants the ball, and Kacanicic doesn't play the ball to him. He plays the ball instead in this direction, and it's quite easy for the goalkeeper to pick it up. So it wasn't the optimal pass choice. But what I said, of course, is what we don't know. Well, say that ball had come in front of Tankovic, who's running there, then that actually might have been a better chance than the one that if he passed out to the wing there. Okay, so we looked at this. This was the pass probability map for this, and the pass he chose wasn't the optimal one. But now we're going to combine this with value. So here is the pass probability thing. Here is our expected threat. Now, there's a little complicated thing here, but we've always gone left to right in expected threat. When we're plotting an opportunity, it's a little bit easier to plot it in the direction of the play. What I'll do is I will rotate this matrix, and what we do is point by point, we multiply together the values here, which is the probability of a goal given the pass is successful, with all the points here, which are the probability the pass is successful. And so that gives us the probability that we'll score a goal given we attempt the pass. Okay, so now it says what is possible and also the value of what is possible. And that is what's displayed here. That is the product, point-by-point product of those two heat maps. And this tells us actually that we have a 12% chance of scoring if we do it there because it's a little bit more yellow, and it's a little bit less yellow in this area where there's a lower chance of pass success. So this pass, if it was perfectly weighted, would be a 6% chance. And now we can actually say, well, what is the best pass to choose in this situation? There's all sorts of limitations with the model, but the model tells us that the top right hand, the top pass, the one to Kjartansson, this one is the best one to choose. So what we have now is a general method for evaluating whether taking a particular pass alternative is a good thing to do or not. But what we kind of need, well, we still need context, right? So we've now got a new value model, one that combines space. And I like to call it expected threat off ball. So we're thinking about what happens off the ball with expected threat, not just what happens with the ball. And the problem that now comes up, or it's a problem, but it's the most interesting part of it all, is there are so many movements going on in a football match. The players are moving in lots and lots of different ways for lots and lots of different reasons. Sometimes they're synchronized in their pressing, sometimes they're man marking, sometimes they're running into space to open up for another player, sometimes they're opening up space for themselves. So there's all of these movements going on, and we need now, if we're going to do this thing properly with context, we need to add this context for each one of these things. Now, I've developed a series of methods together with my colleagues at 12 Football. We call them kind of bespoke metrics, so metrics for measuring different parts of the game. Because when you're scouting, if you're working in a professional team and you want to scout different players, you want to know the skill sets of the players. So I'll show this with this particular example. It's an example from Manchester United. And we can see the movement here. It's Marcus Rashford running on the left wing. And he receives the pass. I'll just show it one more time. Receives the pass. And up here is a representation of that pass in particular. The arrow is the pass. Here's the player making the pass. And here is the area opened up by Marcus Rashford. The thing I want you to pay specific attention to is the fact that he has to slow down very slightly when he takes that ball. So you can actually think about the value of Rashford's run is not just the fact that he manages to receive the ball. If he'd received the ball even further forward, it would have had more value. So if the pass had been perfectly weighted so that the ball was played in front of him, what this model tells you is that he could have got more value with the ball being passed further forward. And so we can actually now evaluate, this is putting the context in, we can evaluate the run, not in terms of what actually happened where he got the ball, but in terms of the space that he opened up for the pass. So when we're evaluating the passer, we'll give the value of the pass, and when we're evaluating the runner, we give the value of the space that's been opened up. An important point here is that sometimes the player who's running does not actually receive the pass. But because he or she is running, they open up space for their teammates. And this is an example of this. This is also from Manchester United. This is Luke Shaw. I'll show you the video first. So Shaw is going to come from, here he goes. He's going to run here. And he takes a few defenders. He moves the play over when he makes this run. Show it to you one more time. The play moves over because he's making the run, and then it opens up for space in the other direction. Of course, it doesn't result in a goal, but it does result in a successful pass into the box when he makes that run. And so how do we evaluate that run? Well, we call this a disruptive run, and we evaluate it in terms of the space that it opens up had he managed to, so he could have received this pass, and that has a particular value. He would have opened up and could have received the pass in the box. There's many, many different ways that you can evaluate these types of things. And as I've said, and this is something that you can think about doing in your exercises, you can start to think of different ways in which they open up. So this is now space creation. This is sprinting when pass event occurs, but not receiving the pass. But you get the value of the resulting pass. So let me give an example of this. This time I think it does result in a goal. So in this case, both James and Fernandez get value for performing the runs and opening up space, while Pogba gets value for actually receiving the ball when he made the run. And so in this way, we can decide what actions are important, and this will vary a lot between teams. They like to have runs in different ways, and it will vary a lot about how you're scouting a particular player. But you create those rules, but then you use the basic idea of pitch control times expected threat in order to assign a value for these particular different actions. The possibilities for this are pretty much endless. It really depends what you're trying to value, but at the ground, you have this same model of value. This allows us, and I think it's nice to show this, and it probably goes beyond what we're trying to create in this particular course, but you can start to now then break down the values of different players. And here I've taken Zlatan Ibrahimovic. I think this is very interesting because obviously he's in his older playing days, and running all the time is not going to be his strongest point. Maybe I should be careful what I say about this, but you can see here that he still does a lot of target value runs. So when Zlatan runs, you pass him the ball. He does less of the disruptive runs compared to other players in the league. Well, someone like Firmino, and this was actually the inspiration for us creating this metric in the first place, someone like Firmino does a lot of these target runs and disruptive runs and potential runs, space creation. He does a lot of those runs and generates a lot of value. And this is one of his strongest points in the Liverpool team. He keeps running and keeps generating the space for his teammates. Maybe it's him who's scoring the goals, maybe it's someone else who's scoring the goals, but he keeps working at creating space for his teammates. So just like we could make, and these are for on-ball data, for standard expected threat metrics, you can see that he's still in the top 80% on-ball metrics. But just like we can make for on-ball metrics, we can also make for off-ball metrics the same type of expected threat, off-ball expected threat. So those of you who've been following the course and doing the exercises, you'll remember how difficult it was to create defensive metrics using event data only. What the challenge there was that defending is about what you do off the ball. So it's not always about tackling and getting the ball back. It's about being well positioned that you can always get the ball back. And that's quite difficult to measure with event data. But using this approach, we already have the value of getting the ball back on different parts of the pitch. And now we can use that combined with the tracking data we have in order to start to value these off-ball actions. To give you a few examples of this, very simple one is pressure on shot. What we can see is there is pressure on the shot by Lowton. When the shot is made, the shot's missed, and there's pressure on the ball by Lowton. And here we actually use the expected goals model as our value model, because we have the expected goal of the shot by Martial and the fact that he misses it, and then Lowton is the nearest player putting pressure on. This can be automatically identified, and we can find out, we can assign a value to that particular action. So now we're looking at pressure on pass, exactly the same principle, but this time we're using expected threat. And in this case, it's actually Martial who puts the pressure on the shot. So if you look at this, pressure on the pass. So here, Martial runs up, puts a bit of pressure on. It's not the biggest pressure in the world, but he's the nearest player. And when the pass fails, we can give him the value or the credit for disturbing that pass. It's not a very dangerous situation. So the expected threat, the failed expected threat by Sanchez is just 0.01. But then Martial actually, his pressure leads to the ball being regained in a place that Manchester United can maybe start to attack from. So he gets a different value based on where they recover the ball. You can also measure things like synchronized pressure. This is a nice example of synchronized pressure. Here we can see that Burnley, surprisingly, for once, they start to put pressure on Manchester United. This isn't the point that I'm interested in. This is the point that I'm interested in. That Maguire is now under pressure, but not only is Maguire under pressure, if we watch it one more time. So watch carefully when Maguire is under pressure. It's not that it's just him who's under pressure, but all three Manchester United defenders are under pressure by Burnley player. 1, 2, 3. Okay. Yeah, sorry, it wasn't this one. 1, 2, 3. And that's exactly what is required if you're going to play a pressing game. You have to have all of the defenders under pressure at the same time so they can't just pass their way out of trouble. One last example. There's kind of endless ways in which you can do this, but let's take one last example. And this is a failed marking example. So now we're going to look at a long distance pass, and we're going to look at the player who should have been marking the player who receives the pass. So the ball is passed into the box. Fernandez receives the ball. Lindelöf is the one who made the pass, but Koch is the person who was failed to mark Fernandez and let the pass go by. And it's a very high expected goal chance for Fernandez, very high also expected threat pass by Lindelöf, and the failed marking then goes to Koch in this particular incident. So we can identify when a player isn't marking the person they're meant to be marking, and we can then give them a value on how dangerous the chance was that resulted by this failure to do the marking. I'm going to finish this lecture by more giving you a pointer in a direction of what can be done next. And I've outlined very strongly this method for working out off-ball expected threat by multiplying the value, the expected threat, by the control to give you an idea of what would happen if you chose that pass alternative. But what that doesn't do is it doesn't tell us, we haven't calculated expected threat using the tracking data. Okay, so one of the problems that we've come up with loads and loads of times is we see a long pass, for example. Now, if that pass is played into an organized defense, a well-organized defense, then there's a lot less chance that it's going to result in a goal than if the pass is played to a counter-attacking player who's then one-on-one with the goalkeeper. So what we really want to be able to do is we want to be able to use the tracking data to also give extra context to our model and improve the expected threat model. And that's what I'm going to close with and give you some pointers in the direction of how you can do that. So here's an example, and this is, so often this idea, I think it's an historical name, but there's this name called packing. And packing is how many players that you take out with a particular pass. This is a lovely example of taking out lots of players with a pass. So I've overlaid here, this is the tracking data before the pass is made. This is where the ball is received by the player running onto it. And obviously this pass is very valuable, both because it lands near to the goal, but it's also valuable because it plays through so many players. And what we can do is we can refit our model, and that's what's shown here. This is, we've taken a logistic regression and a linear probability, exactly as we did in lesson 4, but now we've included how many players that the ball has gone by as a feature. So what we do in this case is we take features from the tracking data, in this case how many players the ball has gone past, and we add that to our model, and then that tells us the value of making that type of pass. Without tracking data, we give this particular pass a value, an expected threat value of 8.1%. Once we take into account the packing that's occurred here, we give it a value of 11.2%. So this allows us to both to evaluate players in terms of how good they are at passing through or over players, as well as making these types of long distance passes. And when we do the regression, we get regression coefficients which tell us what are the important criteria for this type of thing. I'm not going to go into all of the details, but the key idea is this of taking features from the tracking data, putting them into your regression model, as we did before for the expected threat, and then fitting that in order that those features of the tracking data also allow us to evaluate the model. And here's just a few examples of this. These are some passes by Chelsea. First pass is going to go here. It's very much one of those to the back post passes. Fortunately, it doesn't result in a particularly good goal chance. Then this is another example. So pass in the box is 5.9. So everything is multiplied by 10 here, by 1,000 here. So this pass here, 5.5% increase in the chance of scoring. Actually does result in a goal in this thing. These little passes, they're just not 0.8% chance in the chance, but that one is a 4.1% chance. So we can start to evaluate not just where they're happening on the pitch, but how many players that these particular passes are going past. And we can do the same with dribbles. So before, if we had a model of dribbles, we basically just have the data of how close it was to the goal, and the closer it was to the goal, the better the dribble. But now we can also look at the velocity of the player and the direction the player is going in. So if the player is, of course, dribbling towards goal, then it's a more valuable dribble than if the dribble is away from goal. And we can also look at the velocity of the player. When players are dribbling at high speed, that has a much higher value than dribbles at low speed. Again, the idea is to fit a logistic probability model, a logistic regression to the data, and then that allows us to evaluate and give different values to dribbles. Here are two concrete examples of this model in practice. This is, I'll replay that so you can see that one again. Here the dribble is at high speed, and because the dribble is at high speed, the dribble wouldn't be given that many points in a standard model, but because the dribble is made at high speed or a higher speed, we can actually see that it's worth a lot more. I don't know if that results in a goal or not, but we have this on a 7.6% increase in the chance of scoring. And then, similarly, this is another example by Sterling, but this one is a low velocity dribble. And so a dribble there would normally be worth quite a lot, but it's not going in the direction of the goal. And so by including the tracking data, we know that that dribble is actually worth a bit less than we might have otherwise assigned to it. What I like about the approach based on making regression models is that we can actually see the importance of the different factors in any particular dribble. We fit the regression and we put in the characteristics of the dribble we're trying to assess, and that can tell us what makes it a good dribble. So in this particular case, the distance from goal, which is very nearby, makes this a very good dribble. And various qualities of the x coordinates and the y coordinates also make it a good dribble. So this tells us what is it exactly about this dribble, and in particular its distance to goal in this bit. Speed just has a small effect there. We can actually say why it is a good dribble. And again, if you're in a scouting situation, that says I'd like to know about good high-speed dribblers, good general dribblers, players who dribble in dangerous areas, that can dribble near to the box and so on. Those kind of qualities can be picked out by fitting first a regression model and then using the coefficients of that regression model in order to assess the different parts of the play. Now the alternative to that, the alternative to using these types of regression models is to use a neural network model. And the advantage of the neural network model is you get a much, well, I don't want to say a much better fit to the data, because sometimes you don't, but you at least know that you're going to have a more flexible model for fitting the data. And that's been done in various approaches, and probably one of the most comprehensive works of this type is the work by Javier Fernandez, who formerly worked for Barcelona. What he did is he fitted a convolutional neural network in order to evaluate the arrangements of the players and the value of particular actions. So let's make this very concrete. So this is a value of a particular pass. The green line here is the actual pass made, and the blue pass would be the highest value pass made. He's created these different views by first taking lots of data from, I think it was 2 seasons of the Premier League, and he's fitted a neural network model which takes in the positions of all of the players and tries to evaluate whether a particular situation with the velocity and so on and the quality of the pass resulted in a goal. Now this isn't as transparent as the logistic regression approach, but it does give you a very good model, or a convincing model, of what is a good pass and where should the best pass be. And it also allows you to do things like this, which I think is very nice. So he calls this expected possession value, but it's the same thing as I've called off-ball expected threat. What you have here is this is where Barcelona have possession of the ball. It's actually more dangerous for the opposition to score when they have possession here. And now it becomes more probable that they will score. Then it's about equal, and then it goes up, and it goes up again. And over time, you can actually measure the off-ball expected threat that the team is generating. He does it in the following way, though. He breaks it down exactly the same way that I've broken it down already, but it has also the probability of the opposition scoring. So the thing that is called expected possession value includes the probability that the opposition score, but this is the probability of the action being successful, and this is the value if the action is successful. Again, multiplying these two together, the same framework can produce these types of value models. Another approach, and this is done by Will Spearman, who's now at Liverpool, he actually takes three things into account. So he has the expected threat, and it's quite interesting. In this particular paper, his expected threat model is simply the distance to the goal, no more complicated than that. And so this shows the distance to the goal for different points, very close to goal, very far from goal. Then he has a pitch control model, and he's the expert at generating these pass probability pitch control models. And then he has something he calls a transition probability. Now, this adds one extra level to what I talked about before. I said we'll multiply these two together in order to get the probability of a pass leading to a goal. But he says, well, okay, there's actually another thing. There's a decision of the player to make the pass. So this is the probability a particular pass occurs in the data, which he also learns from the neural network. And so he multiplies, in order to look what will happen next, he multiplies this, by this, point-wise, in order to get a final probability of density of scoring from different parts for what's going to happen next. And that gives you the probability of a goal. Now, we're really getting to the edge of... when we get to this stage, we're really getting to the edge of what is research into this area. And it's still an active area of research. Some people are using standard regression models. That's the one that I like best. Other people are using these more complicated neural networks. Google are even fitting models to these types of things. So there's a lot of work going on in this area trying to make these better and better models of football. And in many ways, this is quite a few steps ahead of what even the best clubs in the world are currently using. So this is something that hopefully in the future they'll be using to a much higher degree. But just now, there's very few clubs, maybe Liverpool have got there, there's very few clubs who have actually got into using these types of models. A little bit behind the methods of Javier Fernandez's work. Again, if you want to look at this, you can download the paper. This is the convolutional neural network that he uses to fit to that data. There's other approaches. If you really want to get into this, you can look at a reinforcement learning. So this is a kind of standard learning setup where you use the convolutional neural network. This reinforcement learning is the method that was used for learning chess, for Go, and to play Atari games. So it's definitely been used in game playing. The problem with football, the thing with chess or with Go, you can make so many computerized games. There's a big limit to the amount of games that you have for a game of football. So it is difficult to use this method, but it's worth knowing a little bit about reinforcement learning, because one thing that has been done is there's been some reinforcement learning done on computer game football. So there you can make as much data as you want in order to learn about the problem. And there's been some nice work done by Google creating first a football simulator, then trying to learn strategies on that football simulator, which maybe is a step towards applying that to real football in the future. I've said this a few times, and I think it's worth saying that I do have a bias in this type, or I have my approach to this type of problem. I've said a few things about the neural network type approach, but I think what is important is to go back to precisely what I said at the start. Think about these four things that you want to measure. You want to measure the space created, you want to measure the value of a particular action, you want to measure the context, and then you want to normalize in order to evaluate against different players. That's specifically for scouting. Now you can put the weights in different ways, right? And I would say that the neural network approach it puts the weights very, very much onto the value of a particular action. It doesn't always allow you to interpret what's going on. The approach that I've outlined, where we use a logistic regression model and look to see if the coefficients, how the coefficients for a particular action are affected. And also we say, well, we're interested in this context, that context, and these very specific contexts. They put a lot of weight onto the context. We make an underlying model using the value in the space, but then context is the most important part. And I think that's probably what I would emphasize for you as well. There's a big temptation when you know a few machine learning methods to say, let's just throw everything at it and try and learn football in the way that Google learned to solve Go and chess in their AlphaZero project. But I don't think that that's going to work. I think that football is too complicated for that. It's an open sport with all different types of influences coming into it. You have to narrow down and find the context of the problem you're trying to solve. You're always going to have limitations about what data you have, and you use that available data in order to make a value model, a space model, and then assess things in different contexts. So making a dribbling model which evaluates high-speed dribbling, making a pressing model which says you have to have 3 players pressing at the same time, making a passing model which includes these packing statistics, playing past players, making a model of opening up space and running into space. So each action that you're interested in football should be modeled individually. Of course, I've said this, it should be simplicity in model, and I've said there's lots of different models here, so maybe that's not simplicity. But the simplicity here is that you take the phenomena you're interested in and you build your model of that phenomena. And that is keeping it simple, trying to answer specific, simple questions about your data rather than building complex models of the whole of football, which I think will never be able to be made. Thank you.